There are two major categories of energy, kinetic and potential. Stored energy due to an object's position or condition is called potential energy. A car battery and an unlit firecracker are examples of potential energy. A wind turbine has the energy that all moving objects have, kinetic energy. A wrecking ball has both kinetic and potential energy. The compressed spring turns into kinetic energy and causes the spring to fly upward. This lesson will focus mainly on gravitational potential energy. When the wrecking ball swings upward, its kinetic energy turns into gravitational potential energy. The higher an object goes into a gravitational field, the larger its potential energy. The mass of an object also contributes to its potential energy. If the wrecking ball had a greater mass, it would have more potential energy and could do even more work on the wall. As the man lifts the weight upward, he increases its potential energy. The potential energy equation shows us that the height of a mass is directly related to its potential energy. Doubling the height will double its potential energy or stored energy. Since weight is mass times the acceleration due to gravity, we see that potential energy is also equal to an object's weight times its height. The second equation is not on your reference table, so memorize it. The most common way to change an object's potential energy is to change its height. So the change in P.E. is mg times delta H, or the object's weight times its height. Let's use the equation you just learned to solve a problem. What potential energy is gained when a 100 kilogram object is raised 4 meters straight up? The change in potential energy equals mg delta H. Plugging in the mass and the change in height, we get a potential energy change of 3,920 joules. What potential energy would be gained if an object were moved 4 meters to the right? Since there is no height change by moving 4 meters to the right, there is no potential energy change. An object weighing 15 newtons is lifted from the ground to a height of 0.22 meters. Find the object's change in potential energy. Since we are given the object's weight, we don't use mgh, but weight times the height change. Whenever you are given newtons and not kilograms, we know that we use this equation. When we plug into the equation, we get 3.3 newton meters, or 3.3 joules. Let's summarize what we've learned. Potential energy is the energy an object possesses due to its position or condition. The potential energy an object has depends upon its height and its mass. Height has a direct relationship with potential energy, and so does mass. Tripling the height will cause its potential energy to increase 3 times. And this is the end of my presentation.